Hello everyone, my name is Lakindu and I'm a software engineer and a technical writer. And in this video, we're going to be talking about how you can build a scalable email service using AWS. So this video will not only talk about building email services, it will also help you understand how you can build a backend application or a REST API which triggers events that helps you invoke the email service and notify your users efficiently. So in this video, we're going to talk about a bit of theory. So we're basically going to understand why we should consider the cloud for creating email services and why we should consider a serverless approach for building resilient and scalable apps. And then we're also going to be looking at the sample application that we're going to build along with a basic architecture design of the email system. So we are first going to look at some few mistakes that we might make, and then we're going to talk about what we did and how we can avoid them and talk about an asynchronous approach for it. And finally, we are going to use AWS CDK and get our hands dirty and code it out and deploy it on AWS for all the users to consume. First of all, why should you actually use the cloud for building SMTP services or email services? So if you were using this on-premise services, you'd have to take care of all of the server infrastructure, the security, and even load balancing. So this is quite troublesome for many developers, especially if you're a startup. You might not worry about the infrastructure at first because you have a deadline. You have to meet the product. You have to develop the product in order to get users. So that might be a bit difficult for startups. So in that kind of way, you need something or some resource to take care of this for you. So this is where the cloud comes in. The cloud actually offers you services that you can consume, where you can provision the infrastructure that you require for SMTP servers and freely focus on developing the business feature at hand. And if you are familiar with AWS already, you might know that AWS has a really good and efficient email platform or an email service that they call SES. So SES is also known as Simple Email Service, and it is by far the most cost-effective and scalable email service that I've used on the cloud. SES not only works for small scale, but it also helps if you are sending out blast marketing emails or transactional emails, or even if you are handling mass communication. SES does it all for you. Ideally, you have to talk to AWS first and then request a quota. AWS allocates you a specific quota per month, where this is the amount of number of emails that you get to send per month. And on top of that, they also give you a specific number that you can send per second also. Now these two values can vary based on your use case. The best part of it is you don't have to pay to get started at all. You get up to 62 messages or 62,000 messages per month on SES. And the most ideal part of it is SES seamlessly integrates with other AWS services. For example, if you're building an application on serverless, you would be familiar with AWS Lambda. And AWS makes it really easy to invoke SES directly from Lambda. As within the AWS ecosystem, it offers you tight integrations. And on top of that, when you build these kind of services, you'd obviously need them to scale up and down based on number of requests. And for example, if you were dealing with containerized applications, you'd obviously run them on something like EC2. And with EC2, you always have to pay to keep the instance up and running. But with Lambda, it is completely different. It's basically an event-driven compute service where it's built for the time you use it. So that is where Lambda wins and gets much more cost-effective. And on top of that, it also helps scale up and down very easily. This is why I encourage you to consider serverless for your application development. But then again, you can still use SES with containers as well. So SCS is just another service. You can use the APIs and then use it in your containerized application. So in this video, I'm actually going to be focusing on serverless, and we are going to build a sample backend application. We are going to consider an order processing application. So in that application, a customer would ideally send a post request containing the order name and the items they want in that order. And then we'd obviously have to persist the order in a database. So for that, I'm going to use the serverless database offering by the AWS, which is DynamoDB. And after that order gets persisted, I'm going to send a notification via an email to an administrator saying that, hey, there is a new order, take a look at it. So how would you basically design this? Now, there are a couple of ways that you can actually design this. So let's take a look at this first design diagram. So here we can see that the client sends a post request to this endpoint API resource at the API gateway, and the API gateway invokes a Lambda function, and the Lambda function does two things. First, it persists the order in the database, which is DynamoDB, and then it will notify the administrator via an email using AWS SCS. And then it will send a response back to the client saying that your order has been made. Now, on paper, this sounds like a good solution. I mean, it gets the job done. But what do you think is actually wrong with this architecture? The main issue that I find here is that it's not scalable in nature. Like for small users, like for about 10 to 20 users, this solution gets the job done. But assume that you have around 100,000 users accessing your application at a second or at concurrent rates. Now, all of these services, Lambda, API Gateway, SCS, and DynamoDB, are designed to scale at that nature. But the way we've modeled our architecture or our sequence, we are not leveraging these scalable advantages. So this is because we're performing too much in this Lambda. We are actually creating synchronous operation. So we are first persisting the order and then notifying it, and then we are waiting until SCS sends the email, and then only we send a response back to the client. Now, at that point, there's actually possible number of seconds that you're waiting there. Now that creates a huge latency in the response and drastically decreases your application UX. And on top of that, you practically increase your bill also, because as you remember, Lambda, you only pay for what you use, and you end up invoking the Lambda for a long period of time. So in that way, you actually exhaust your AWS bill as well. So because of that, this architecture is not good for use for a system that expects a high user growth. So let's take a look at the second architecture though. Now this uses a new service. Now this is actually called SQS, which is known as a simple queue service, where it allows you to process data asynchronously. So you push it into the queue and then it can be processed after a while without the client having to wait. So ideally what happens is the same process, the client makes a request to the API gateway, and the API gateway invokes the Lambda. The Lambda will first persist the order, and then it will push it to the queue. After it pushes the newly made order to the queue, it returns the response to the client saying, hey, we've made the order. But after that, the Lambda does not bother anymore. The Lambda finishes its execution after pushing it to the queue. That way, this Lambda finishes its termination and a whole new sequence begins behind the scenes. This is what you call asynchronous processing. Now, this queue will first get the data, and then the AWS Lambda service will poll the queue and then invoke the Lambda that is set to be triggered for this queue. And after that, this Lambda will receive messages from the queue, and it will take the messages, process it, and notify the administrator by invoking SCS asynchronously. So these two, now as you can see, this step and this step is completely decoupled. So in this way, we are actually creating a more scalable architecture, and on the other hand, we are actually decreasing the latency also. And the most important thing is we're creating reusable code. So with this, what you can do is you can later integrate another feature, such as, let's say, the order changes state. So same thing, you update the state, you push it to this queue. This queue will process the data via a Lambda function, and the Lambda function will then ultimately notify the administrator via the email. So this is where we introduce code reusability and architecture decoupling and ultimate scalability. Ultimately, you have good scalable resources here. So this is the architecture that we are going to design and implement, and let's build it out using AWS CDK. So welcome back, and let's get started with the coding part of this video. Now, the code that we're going to be implementing in this video is already available in this blog post that I've written about this video, and I'll link this in the description below so you can follow along with me as I code it out. So I've listed out all the steps here that we need to follow. So let's just get started and see where we go with this. So to get started, you will need a couple of prerequisites. So I recommend installing Node. If you don't have Node, just go to Google and type Node.js, and then go to this website and download the latest stable version for your OS. So I've already installed it. And after you install it, go to your terminal and type node-v, and it will display you the current version, indicating that you've installed everything correctly. And after that, you'll also need the AWS profile locally configured on your machine. So for that, I recommend installing the AWS CLI. So you can download it from Amazon itself. So just go to this and click on this, and then click on your OS preference here. So for me, I'll click Mac OS. And then you could follow this, you could download it, and then you can install it following the instructions they've shown. And after that, make sure that you've configured an IAM user with administrator privileges so that the AWS CDK can use that AWS profile to deploy your resources on the cloud. So after you've done that, you can install the AWS CDK library or the CLI for that. So for that, we'll just go to AWS CDK CLI, and for me, I'm using Node, so I'll just click on npm, and then you can install that using this command right here. So I've already installed it, so I'm not gonna do that again, but you can confirm your installation by running this command. So just go to terminal and type cdk -- version, and that will display the current version that's installed. So if you get this, you are successfully good to go, and we can get started with the coding part. So first off, we need to create a new project using CDK. So for that, I'll just navigate to my desktop and I'll create a new directory. I'll just call it email. So I'll just call it order application, and I'll cd into it. Okay, and so what you're going to do is we're going to click CDK init app, and we're going to type language TypeScript. And so for this flag, we can actually specify any language you want. So CDK supports languages like Java, TypeScript, JavaScript, C#. So you can code it out in your preferred language, but for this tutorial, I'm going to be using TypeScript. So after you successfully installed it, you can open it in your preferred IDE, and I prefer code, Visual Studio Code. So I'm just going to open up this directory in Visual Studio Code, and this will open up the directory right here. And once you open it, you'll head on to lib and open up this file, which is the order application stack. All of our resources in CDK are scoped to a particular construct. So this is why we code it inside this constructor. So we can just remove out the sample code, and let's get started with our architecture. So if I go back to our presentation before, so we are going to need the API gateway. We're going to need two lambdas. We are going to need the SQS and SCS and DynamoDB. So with that in mind, let's first create a few directories that will help us. So we'll first create a new directory where we're going to store our business logic for our lambda. So we'll just call it lambda. And inside this folder, I'm actually going to create another npm project to store my required libraries for it. So for this, let's just open this up in an integrated terminal and type npm init. And yeah, we'll just give our defaults. Yeah, we'll just give our defaults for this. And then once we are inside this library, I'll just copy over the package.json. So we have all the libraries that we need here. So under dependencies, we would have 2 dependencies here. So basically we are going to use AWS SDK and the Nano ID. So why we use the AWS SDK? We are going to use it to get access to DynamoDB, SES, SQS, and all those good stuff. And Nano ID, what I did by use it was each order, I'm going to have an order ID. So the order ID would be a unique number or a unique Nano ID. So after you've added the dependencies, let's just click npm install and install the dependencies. And I also recommend adding a git ignore. So we can actually prevent our node modules from being committed. So after that, we can get started with our Lambda logic. So for this, I'll just create another sample file called lambda.js, and I'm just gonna copy the code that we've written for the application. So I've already written this in the article. So we'll take that and we'll see in detail what's going on. So initially, we import the AWS SDK and the Nano ID. So this exposes a nice function which allows us to generate a random string, and we need SES, document client, and SQS. So why have I specified it in the US East one? So that is my preference. I want to deploy it in the Virginia region, but you can use it in the region that you prefer. But note that some of these services such as SES are not available in certain regions. And after that, I'm actually taking an environment variable, an admin email. So this is an environment variable that I'm passing into the Lambda function. So we can actually bring this inside this Lambda function, because I think this is only, yeah, we are only using it here. And the table name and the queue URL. So the nice part of it is SQS offers us a direct method that helps push data into the queue by referring to the queue URL. So that is why we need this URL. And the table name, I'm using it to access document client. So using the event here and getting the body. So this, all of this, we're going to be passing it from our API gateway. So they're constructing an item that we're going to put into our database. And yeah, we're going to put that into order table, and we are going to persist it on DynamoDB. And after we've persisted it, we are directly going to push it to the queue. So we are going to call SQS, and then we are going to call the method send message. So the send message accepts 2 parameters, which is the queue URL and the message body. So we are going to pass the queue URL, and then we are going to pass a JSON representation of the order along with the admin email. So basically what we are going to do is we are going to pass the email outside of the emails lambda. So what all that lambda, second lambda, is going to do is get the order and get the email and send the order information to this email. So this brings us to our second lambda, which is process order. So as you can see here, we are going to be taking the source email. Source email is practically the sender email, and then we are going to send it to the recipient, which we've passed from this. So this is the admin email, this is the recipient here. So you can see that I've added it here as the destination in the 2 addresses. And we are going to construct a simple message here along with the new order received, and items are, these are the items. And we are going to send a text-based email, but you can, SCS also allows you to send an attractive template email. So after we've written down our Lambda functions, let's actually start provisioning the infrastructure that we are going to use. So let me just open up this file, the lib file, inside the lib directory. So inside this stack, we are gonna scope all our resources into the construct. So open up this file and we are gonna add this code, which I'm gonna be showing you right now. So let's just copy it from the article. So that's available right here. So let's just let it load. Yeah, this one. So let's just gather the infrastructure. So anything within the constructor, we're gonna grab it. Yeah, we're just gonna copy this bit and let's just paste it. Okay. So as you can see right out of the gate, we are missing a lot of imports. So let's just add all our imports. So let's import the modules as we need it. So we need SQS. So we're gonna get it from CDK lib. So we're gonna get it from CDK lib. So that's, as I'm aware, it's like this. Yeah, and SQS, and then we're gonna get lambda. So we'll also need IAM, and we'll need API gateway, okay. Sorry, I think it's AWS API gateway. Yeah, okay. And we'll also need lambda event sources. So we'll walk through each of this one by one and understand why we are using all of this. Yeah, so I think we've got all of it. So we just need duration. So we'll just import that from AWS CDK lib. So that's from, yeah, awesome. So where else? So yeah, we need DynamoDB. Okay, so initially we are provisioning the queue. So with AWS SDK, it's pretty easy to provision your queue or your AWS resources. So all you have to do is it provides you classes. So what you can do is you can instantiate an object of each class and provide a unique ID for it, and then provide certain props for it. So basically props are basically the configurations for it. So as you can see, all of these infrastructure management follows the same same steps. You create an object, you pass in the context. So in this, we are scoping all of our resources to this construct. So that is why we are calling this keyword here. And then we provide a unique ID. So this ID must be unique in this stack. And then the props for it. Now these props differ based on the resource that you are instantiating here. So initially we are creating an SQS queue, and we are calling it AWS order processing queue, and then we give a queue name for it. So the documentation is also here. So we are creating a standard queue, not an FIFO queue, not a first in first out queue. So if you're creating a FIFO queue, you'd have to pass in this configuration. So you can see it requires a Boolean. So if you were to give this, we need to give this in true for a FIFO, and then this should end in .FIFO. So we are gonna stick to our standard queue, but if you are gonna use the FIFO queue, this is the way to go for it. And we're also setting a visibility timeout. So the visibility timeout basically says how much time should the consumers basically be prevented from processing this message. So by default, they give the timeout of around 30 seconds. So, but I've set it to 45 seconds. And then we are going to create an event source. So the best part of these serverless architectures with AWS is that freely integratable with other AWS services. So for example, with SQS, you can easily set up integrations with AWS Lambda. So all you need is an event source mapping. So for this, you can import the event source library or the module, and then create an instance of an SQS event source. So if you're creating an SNS, so you can create an SNS event source and a DynamoDB event source. That is basically for a stream. And then you pass in the queue, or the which queue you're gonna have the event mapping for, and the batch size. So batch size basically says the number of records that the Lambda will retrieve when it invokes your function. After that, we are basically done with this. So this is one part of the infrastructure done. So if you go back, so this part is done now. So we've set up the integration from the SQS to the Lambda. The Lambda already we've discussed, it notifies administrator by the email. So this part is done now. So now we can take a look at this part and see how it works. So after that, we need to configure one more thing. We need to take care of the event source. So for this, we are going to add the event source as the Lambda SQS event source. And one more thing that I did not mention is SCS requires certain permissions. You need to allow the Lambda function to consume AWS resources. Even if it's a DynamoDB table, you need to allow Lambda to access DynamoDB. So like that, you need to allow Lambda to access AWS SCS. So for that, you have to create an IAM policy for the role that is already being created for the Lambda function. So basically what I do is I create the Lambda function here, and then so this is the email processing Lambda, and then we attach the event. So that means with the event source that we created here, we add this event to this Lambda. So now this Lambda is in charge of this event source. That means we successfully mapped that order queue Lambda event to this Lambda function. And then to this Lambda function, we are assigning a new IAM policy to the already created IAM role, where we say allow this Lambda function to perform the send raw email, send templated email, or the send email function of SCS. And for this, you can basically specify which identities that can use this, that can to execute this operation. So with this resource flag, you can basically say only this identity is allowed to consume this. So we've created the asynchronous tree, we can start focusing on the DynamoDB table. So this is this table. So we are creating an order table here. And for the partition key, I have the order ID, which I've created, which I'm passing here. You can see it passed here. And I'm going to be provisioning this on paper request. For the encryption, I'm just going to use the default encryption method, where we will be using the master key owned by AWS. And since this is a demonstration, I'm not going to be focusing on point of time recovery. Now that we've done with this table, we can start implementing these two phases now. So what we're going to do is we are going to create a Lambda, and then we are going to create the API gateway. We are going to create a resource for it that maps this endpoint, and we are going to invoke the Lambda function using the Lambda proxy integration. So we are going to create the Lambda function. So we are going to get the code from this directory, and then we are going to pass in the handler function, which is basically lambda.createOrder. So this should be lambda. I think it should be lambda on top also. So lambda.processOrder. So we're basically referring to these functions that we created here inside this directory. So this directory is obtained from this line, and I'm just going to use Node.js version 16 and above as my runtime. And I'm going to allocate a memory size. So rather than using the default of 128, I'm going to use 256 and give it a bit more longer timeout, 10 seconds. And remember, we talked about three environment variables. So these three environment variables. So this is where we are going to be passing the environment variables from. So for the admin email, I'll just pass in my email. So let's just pass in my email. So I'll just pass in lakindu@gmail.com. Yeah, okay, that's cool. And then still, so earlier I mentioned that each Lambda function needs to have specific permissions to access other AWS resources. And the best part of it is you don't have to manually create IAM policies like I did here. This is for special cases, but for most cases, the AWS resource has you covered. So basically you can just type in the AWS resource that you want, and you can just click grant. So, or you can either type, grant, and then you can select what permission level you want the targeted resource to have. So here, if I want to put full access, I can just put full, and then I have to pass in the grantee. So to which resource am I giving full access to? So I'm just giving it like this now. But this is not recommended in AWS. So what we do is we follow the principle of least privilege, where we give the user or the entity only the permission required to get the job done. So for this, I'm just gonna give write permission, and so that is to write to the database, and also it needs permission. This Lambda function needs permission to push the data to the queue as well. So we're just gonna send messages, so they'll get the permission. So the method that we call, so you can see sqs.sendMessage. So sqs.sendMessage to the create order function. So that way our Lambda function is now authorized to access this DynamoDB table and only this queue. So again, we are following the principle of least privilege. We are passing only the required permissions here, nothing more, nothing less. And after we've created the Lambda function, we only need to create the API gateway. And that is also really simple with CDK, basically the CDK lib. So we create the REST API, we give it a name, and for this REST API, we add, resources. So we get the root. The root is basically, so if I were to illustrate this, the root is practically the base path. So that is this path right here. So the root. And after that, we create two new resources. First, we create a resource called orders. And then we append another resource to it called new. So this is the resource that we are creating here. So this is equal to new orders. So once we deploy the API gateway, you can see that we are gonna have a resource like this. And then for that resource, we are gonna add a method called a post method, which is actually a Lambda integration, which is a simple way of integrating a Lambda function to the API gateway, and we are passing our create or a Lambda function. And we can also add certain props for it. So for this, I did not add an authorization type, but you are free to add your own authorization type. For example, you can have a Lambda authorizer, a custom authorizer, a cognito authorizer, or even specific IAM authorizers, which are basically not that used. If you are developing web apps with Cognito, you can use the Cognito authorizer to authenticate your users efficiently. But for this, I'm just going to click none. And that's about it for the infrastructure and our full stack application for the backend. Let's deploy this and see. So open up your terminal, and the first command that you're going to run for the first time. So this is only needed for the first time of your deployment. You should run the command CDK bootstrap. So what this command does is it practically creates an S3 bucket, which will store the deployment information and the CloudFormation templates required to deploy this infrastructure. So we need to run this only for the first time. So after you've run this command, you should get this output. And now that we are ready, we can run the command CDK deploy, and this will start deploying our stack onto the cloud. So this will take some time. So let's just wait until this finishes. So let's just click Y and deploy these changes or create our stack on AWS. So now you can see it's deploying it right now. All right, so that took me about 3 minutes to deploy. So after you successfully deployed, you should get this output. So this is basically the invocation URL for our API gateway. So let's just visit AWS console and see our CloudFormation template. So let's just go to CloudFormation. So if you go to CloudFormation, you can see the template deployed. So this is the odd application stack that we just now created. So you can see it's created complete. And after that, let's just go to API gateway. Just see our resources. So you can see that once you go to API gateway, there's our email service, the API that we created. And You can see the endpoint orders new, and we have the resource method for it that executes a Lambda proxy request where it invokes this Lambda function that we created quite properly. And if you go to Lambda, you can see the two process order and create order. And finally, let's just go to DynamoDB. You can see once you go to update settings, so here's our table that we just provisioned. And let's get started with our email setup now. First things first, guys, if you're running on the sandbox environment of SES, you will need to have a verified identity for both your sender and the recipient, because you are in the sandbox. But once you are in the production mode, you will only need to have a verified identity for your sender email, and the recipients can be any user. But beware of bounce emails, because that can significantly harm your sender reputation. So always try to maintain a good sender reputation when you try to send with SES. So let's go to our SES console. So let's just go to account dashboard. So you can see I am in the sandbox environment, and I have a maximum rate of 1 email per second and 200 emails per day. So now let's go to our verified identities and create our identities. So I anyways mentioned one of my emails as an as a admin email. So we are going to click create identity, and let's create that identity. So I'll just enter the email, and and we'll create the identity with default configurations. And you can see initially it is in unverified status. So what SES will do is SES will send an email to this address to check if it really exists. And then once we approve the email, SES will mark this email address as verified. So let me just verify it for you and show you how it looks. So once your email address has been verified, you can reload the page. And yes, you can see now it's been verified. And likewise, let me just create my other verified identity, and I'll just include that. And I'll just include that, and I'll create another identity for that. And you can see that's also in the unverified status for the moment. So you can go into your inbox and verify it. And once you do verified, you can reload it, and then you're good to go. So now let me just replace this email address with the source address in my SES Lambda file. So the one I use to send emails from. So let me just go to Lambda, and let me just click on, where's the Lambda? So I'll just add it here, and then we'll have another deployment. So another easy command that I recommend is CDK deploy, and use the hot swap flag. So what it does is it compares the diff, and then if it needs a full deployment, it will deploy the entire CloudFormation stack again. But if it needs to update only one Lambda function, it will update that. So this is very easy, and it is less time consuming. Okay, so you can see that it took only 50 seconds. And now we are done. So we can copy this URL, and we need to submit a post request to our API. So let's just copy this URL, and I'm gonna use Postman. So I already have this set up, so we can just replace this bit. So now we are good to go. Post request. And so we are gonna send a sample order with the name of my sample order, and we are gonna create 3 items in our order, which is milk, cereal, and eggs. So let's just send the request to AWS API Gateway and see what will happen. So awesome. So you can see that we created an order called my sample order, and this is the order ID that NanoID generated for us. And we also got back the message ID that SQS actually pushed. So we can use this message ID for tracing and debugging purposes. Alright, so this is the email that I have here. So you can see that I have a new order received, my sample order, and these are the 3 items. I do hope that you learned something interesting about email services and how you can utilize AWS to build an effective and highly scalable email service. And I hope to bring you guys a lot more content. So thank you guys for watching. And if you do enjoy this video, give us a sub and give this video a like, and comment down below on what are the topics that I should cover next.